Okay, well, thank you very much, Penny, and I appreciate Sitcom and SOC both for helping with practice standards and for doing this really important process of training on those practice standards. So today we want to focus on the 393 filter strip standard, and just to let you know, it has had a change last fall. The national standard was sent out, and there are some significant changes from what we have been used to in the state. I know I've been here about a year and a half, and I've heard a lot of people concerned about the complexity of the filter strip standard. And I have to tell you that some of the complexity we have been able to address. So as we go through this, I think you will start to see that we have a lot of good management of the filter strip standard, and yet the complexity has been simplified. And I will kind of focus on that, but along with that, I will be definitely focusing on the need to do an excellent job of conservation planning, because if we don't take care of the actual site conditions, then this practice standard is just not going to be effective. And I really believe that the filter strip standard has a real place in Wisconsin. It does a great job of helping trap sediment and helping keep waters clean. But if we don't use it correctly, we're going to get ourselves in trouble with it. So that's going to be mainly the gist of what I will do today, is go through the standard itself, the technical note, and then show you the job sheet that was created to support it. I will also talk a little bit about the change from the old way we used to do filter strips to where we're at today, and why some of those changes have occurred, and just let you understand the differences between the old and the new. So what we're going to be looking at today is we're going to be looking at some upland treatments. So if we have time at the end, I'm going to take you on a journey of upland treatments and talk quite a bit about conservation planning on the uplands, and not forgetting that that's the key to the success of a filter strip. So we will talk about that. You'll also hear me say that without some of the other practice standards associated with a filter strip, we're not getting the controls that we need with filtering surface water. So specifically 590 nutrient management, 595 pest management, the no-till standards, the reduced till standards, the contour buffer standards, the 342 standard, critical plantings. All of those are absolutely vital piece of the filter strip standard. Some of that was incorporated into the standard in the past. We like to keep our standards pure, and we like to refer people back to the other standards, but I'm just telling you that when all of the standards come together, that's when we have the best treatment. I know we've had Ray Angeletta in the state on several occasions, and I think I've heard him say that the filter strip is nothing more than a diaper. I totally disagree with that, but if you're not attending to your uplands and you're not looking at big picture conservation planning, he is absolutely correct. So I think we are better than that. So you will hear me kind of really focusing on making sure we're pure to those uplands, because if we're not, the filter strip is just not going to last and not going to do what we need it to do. So that's me on my soapbox. So a couple of things. What we had been doing with the national standard update is to incorporate a lot of the information that's hidden behind the scenes in the sciences behind our current model of soil loss software, which is Russell 2 currently. So what we're looking at now with the filter strip standard is we're looking at making sure that we're focused on our slope. And in the olden days, we only looked at percent of slope. Now we're looking at length, steepness of slope, both. We're looking at the ability for the soil itself to infiltrate, so that we know we're going to be reducing our erosion or our runoff. We're now looking at the residue levels. We're looking at the soil loss tolerance based on the soils on the site. We're looking at climate data. So we're looking at a lot of things, and we're basically focused on our contributing watershed. Those of you that spent a lot of time with those little charts, they were so handy and easy to use back in the day. Those little charts would say what's the steepness of the slope in the first 100 feet next to the surface water. Then you'd get a factor. And then it would ask you, what about the next 100 to 300 foot? And it just wanted a steepness. That's all that was being calculated into that picture. So you had only 300 foot of protection. On the new standard, we're looking at all contributing uplands. So that's a big deal because the producer that's doing the filter strip may not have control of all the uplands, but the bottom line is that filter strip has to accommodate all that upland because it's going to be addressing it despite who the owner is. So you're going to see those differences in this, and so we talk a lot about contributing watershed on the uplands here. So I also want to say that in the past we had these really handy little charts, and it said the minimum width of a buffer based on this criteria that you could measure is 20 feet, and the maximum is 70 feet. And then it went from 30 to 70 feet maximum, from 50 feet minimum to 80 feet maximum, 60 foot minimum to 80 foot maximums, and we just kept going down the line. This new standard basically says you have to have this minimum, and in the standard that was done, I believe it was put out maybe 2 years ago or a year and a half ago, was pretty complicated because it said you have to prove that it's going to make a 10-year life. And that's absolutely true. A filter strip, just like a grass waterway, needs to have a 10-year life. That's what it's designed to do. So if you're sedimenting in quicker than that, then you're not going to get the full use of a filter strip. So you need to deal with that. That being said, I know a couple of folks that sat on the SOC committee chatted with me, and I know that I spent quite a bit of time saying, what is that minimum width? And what is the formula telling us? And what's the math saying? And I can tell you that if you are at a tolerable soil loss on your uplands, contributing uplands, and that's a tolerable soil loss according to Russell II, and your area of filter is at a 1 ton loss, so that's tolerable above it, and then you've got it controlled to 1 ton going off the site, then all of those should last to 10 years. And so the math was really complicated, and we thought we had to run it for every single time we designed a filter strip. And I'm just telling you, go ahead and do that. It's a wonderful experience to do that formula. And if you find something that doesn't fit that 10-year model, let me know. But I have run every worst case scenario I can think of. And the minimum widths that are listed in this practice standard, as long as the uplands are treated, we should be okay. So that sounds a lot simpler, and it is, but the whole bottom line is, as planners, we've got to know that those uplands are being treated and they're at tolerable loss. Anything in the filter strip, it isn't too hard to get a 1 ton loss off a filter strip as long as it's inside, which obviously these are going to be. So that's my simplification and a really rapid assessment of what's going on with this. So I just wanted to share that with you before we get started. So the filter strip standard itself, I'm just going to talk about some of the highlights here. We all know that it's a strip in an area of herbaceous vegetation that removes contaminants from overland flow. The purpose is threefold: reduce suspended solids and associated contaminants in runoff and excessive sedimentation before it hits surface waters, reduce the dissolved contaminant loadings in runoff. I will speak just a little bit about that. This is the best model we have to deal with dissolved phosphorus, but it is really a challenge, and it is virtually impossible to guarantee that a filter strip is going to address dissolved phosphorus, because that's flowing off at such a rapid pace that it's going to be very, very difficult to trap it. So we know we can trap sediment, but the dissolved phosphorus is a whole nother battle. This is the best we have, but that continues to be a challenge for us. And I will talk about where the condition does not apply so that we can be real clear on that phosphorus loading to surface water. Reducing suspended solids and associated contaminants and tailwater is also, and sediment to surface waters from irrigation tailwater is also part of the filter strip standard. So this filter strip standard does apply where it's environmentally sensitive areas that need to be protected from sediment, other suspended solids, and dissolved contaminants that are coming off from runoff. But it's really important that we understand where it does not apply, and that is in treated conditions where high levels of pollutants can be anticipated from areas such as your feedlots, feed storage areas, excuse me, milk house waste, manure stacking, direct runoff, concentrated flow from manure land application, construction sites, urban stormwater, and timber harvest locations. So obviously this standard is not designed to handle that intensity of contaminants flowing off. So where the soil loss level is above tolerable rates in the contributing watershed, this practice will not work. Where the predominant source of runoff is concentrated flow, this is not your ticket. So those pose tremendous challenges for all of us planners in Wisconsin because we continue to look at upland treatments and get frustrated because, because we're not positive that they're at tolerable rates, and this practice needs that contributing watershed to be treated. The same with the concentrated flow. If we don't have that treated and you've got channelized gully flowing off of there and it's not treated, then this is not your practice standard. So we're going to assume that grass waterways are under control on the uplands as well. Even though they're contributing at a high pace, that's the best that we have. But it is important that we recognize they do need to be treated. Okay, so the general purposes overland flow entering filter strips needs to be uniform sheet flow. The assumption is that we do have uniform sheet flow, and that's the purpose of the filter. So we're not talking about the grass waterways. That's just going to happen. We're looking at those to be treated, but the waterway itself is what's going to be treating it. So this is all about sheet flow and uniform distribution into those filter strips, and we'll talk a little bit more about what that means in the standard itself. Concentrated flow will be dispersed before it enters the filter strip. So that's why it is important to make sure that we'll talk about some of the conditions here, but one of them is that these contour, or that the filter strip itself is close to the contour so we don't get that channelized flow effect if we have grade on the slopes. So that is part of the standard here, and we'll cover that in a minute. The maximum gradient along the leading edge of the filter strip will not exceed half of the upland hill slope percent immediately upslope from the filter strip up to a maximum 5%. So in other words, we do need to have that flat area to help trap that sediment out of there. Filter strips will not be used as travel lanes for equipment or livestock, and there's more information on both of those throughout the standard. A little statement on additional criteria to reduce dissolved contaminants, suspended solids, and associated contaminants in runoff and excessive sediment to surface waters. Filter strip has to be designed to a 10-year life, and that is very clearly spelled out in Wisconsin's Agronomy Tech Note number 10, and that is a filter strip tech note, and the tech notes are placed in section 4 of the Field Office Tech Guide under tech notes. So you can find it there quite quickly. So there's a lot of information on how to plan it, how to do the math to make sure it lasts 10 years, what is the design criteria, a lot of good stuff in the tech note. The current tech notes, you're going to see some differences from what it was in the past. The tech note, I believe, was over 20 pages last year. And what it is now is very simplified. As long as you're meeting your criteria on your treated uplands, it will tell you how to calculate to make sure you last the 10 years, and it will tell you also some other things to make sure that you're not using minimum widths, you're using maximums, or something in the middle that will function if you have additional challenges to that filter strip, and we'll talk a little bit more about that. So the TechNote is there and ready for your use as well. So if you have not visited it, I would strongly recommend that you do. The old TechNote did have a lot of criteria in it relating to seating and the 342 standard, but what we like to do is keep these sorted out because you do need to reference 342 critical area planting TechNote so that you can understand what grasses you should be designing for this. But that is not part of the filter strip. That's just get back over to the 342 standard to design the grasses that you're going to be using, because the information you need for that design is in that TechNote. So it's a combination of two TechNotes. This practice standard for Wisconsin, the absolute minimum flow width for the filter strip will be 20 feet for suspended solids, and that's just the soil, and that's if there is nothing on the uplands to contribute to other contaminants. So in other words, the minimum if manure is applied is 30 feet, and that's an absolute minimum. So we've got 20 feet or 30 foot is a minimum. That does not mean that that's the right distance to be using in all sites. So now we have to look at site-specific criteria to determine our width. But those are the minimums, and they do meet as long as those uplands are treated. The filter strip will be located immediately downslope from the source of contaminants, in other words, the crop fields. The drainage area immediately above the filter strip will have a slope of 1% or greater. So what they're saying here is they do not want a flat filter strip because that will not filter. And so we have to have a minimum of 1% grade on our filter strip. The filter strip is established to permanent herbaceous vegetation. And in addition to that, you're going to be looking at making sure that it will withstand partial burial of sediment deposition. It'll be tolerant of herbicides that are possibly contributing from the uplands. In other words, we're really looking at stiff-stemmed, high-density sod-forming grasses. And if you go to your technical note number 6, your information will be readily available to help you design those filter strips. It needs to be suited to current conditions and includes using soil conditions, flooding frequency, upland herbicide treatment. So you've got to look at the conditions. What are the soils like? What's going to be successful there as far as the seeding is concerned? You need to be able to achieve adequate density and vigor on the site, and that's given ordinary management activities. One of the things that was asked of me by several people is, are you going to allow it to be clipped? Are you going to be allow it to be harvested? And the answer to that is watch out for the program, because the program that you are enrolled in probably has its own limitations and its own rules and regulations. But from the purest filter strip standpoint, we absolutely benefit from harvest of filter strips because that reinvigorates that grass and it allows for more infiltration or some more uptake of the nutrients. So it is a good thing to be able to harvest that. All right, site preparation and seeding. Make sure we do a good job to ensure that we have the species successfully established. Schedule planting dates. Excuse me. During periods when soil moisture is adequate for germination. Obviously, if we don't get a good establishment on these, we do not have a filter strip. So that's a real important part of the picture is being successful with our establishment. If we are removing phosphorus, again, harvesting is a really positive thing to be doing. So we want to remove that biomass from the site, not just clip and leave. We want to actually get it off site, and that's our goal. So that's really important if we can do that, and if the programs allow us to do that. The minimum seeding and stem density will be equivalent to the seeding rate for a high quality, for a high quality grass hay seeding rate for the climate area. Basically what we want to do is just really pay attention to that 342 standard to help you decide what we're going to do with that seed mix. Some of the additional criteria to reduce suspended solids and associated contaminants. These are the additional things that we should consider. Filter strip vegetation will be a small grain or other suitable annual plant. Small grain is not, I mean, we definitely want this to be a perennial grass. The seeding rate will be sufficient to ensure that the plant spacing does not exceed 4 inches. And if you go to the 342 standard, there's additional criteria that will really help you determine how many seeds per square foot are recommended in order to really do a good job of handling this. So filter strips prior to irrigation season, establish them before the irrigation season so that the vegetation is mature enough to filter sediment. That goes without saying. So some of this is pretty common sense, and that 342 standard will definitely help you. But some of the considerations that we do need to look at, filter strip width can be increased, and it should be increased to accommodate conditions to match equipment. That goes without saying. So we want to make sure we're asking about harvest equipment and seeding equipment so we don't look foolish when we're designing these. Filter strips with leading edge on the contour will function better when the gradient, with a gradient along the leading edge. So we want to just make sure that things are going to flow into the filter strips. So seeding rates established, this is something that the 342 standard will also tell you that if you need a higher stem density than a normal density for high quality grass hay, it will do better at trapping and treating contaminants, and that obviously is something to keep in mind when you're designing these mixes. And we need to watch our invasive species and make sure we're mowing and treating so we don't end up getting something other than what we need to filter. Consider reducing suspended solids and associated contaminants in runoff. Increase the width of the filter beyond the minimum requirement if that's what if we need to be paying attention to that. So again, in Wisconsin, our maximum widths over history have been 120. And if we need more protection because of suspended solids coming into the filter strip, it goes without saying that maximums may be required in certain conditions. All right, and then we have a lot here on wildlife and insects and pollinators. I'll let you read that yourself, and that's all new. I mean, that is currently a focus for a lot of our standards. Maintain and enhance watershed functions and values. That's spelled out here. Carbon storage is spelled out. And then, of course, the biggest part of any practice standard that we really have to pay attention to make sure we're following it is to pay attention to the plans and specs section. So what we have done for most of the practice standards, you will find job sheets that have been updated, and those job sheets are designed to make sure we capture the plans and specifications. So we will look at the job sheet very quickly, but what has to be documented in order for it to be proven to meet this practice standard are, number one, what's the purpose of it? Because that's critical when we're trying to figure out what our design, if the design will fit, it needs to look at the purpose. We're going to look at what's the length, what's the width of the filter strip, what's the slope of the filter strip. Those things are critical. We look at the plant species selection, the seeding planting rates, and what the plan is to get it established. When does it need to be planted by? What are the planting methods? The specific care and handling requirements of the seed and the plant material to ensure that the planted materials have an acceptable rate of survival. A statement of that only viable high-quality adapted seed will be used, and the 342 standard is going to take you right to PLS-based, and site preparation instructions so that we know we've got the best shot possible of getting it established. So that is what's in your plans and specs. The O&M is critical, of course, for every practice, but this one in particular, just to make sure that we're doing what we need to in order to make sure that this is going to maintain itself for the life of the practice, which is 10 years. So here we're looking at harvesting is encouraged. We're looking at making sure that we're not allowing noxious weeds in it or any other uncontrolled weed species. We're prescribed burning it if it's needed. Inspect the filter strip after storm events, and this is something that's always critical to make sure that we don't have gullies establishing in it so we lose our value. We also need to occasionally deal with the fact that it may have sedimented in because of these massive storm events that potentially will trap way more sediment than we anticipated. So on occasion, we just need to be looking at that and making sure the landowners know that this is designed for normal 10-year events, not those massive 100-year events. Apply supplemental nutrients. I doubt if that will be a problem in most locations, but obviously if we're seeing stress because we don't have enough nitrogen on the grass or whatever the case is, we need to be looking at that. We may need to regrade and reestablish the filter strip depending on what Mother Nature is going to do to us over those 10 years. And then if it's going to be grazed, it needs to be grazed according to a plan so that we don't jeopardize the integrity and function of the filter strip. There is a little language in the tech note about grazing, so obviously we're not going to let cattle on it when it's wet, and there are certain things that we need to do to protect it. So in a nutshell, that is the practice standard. So I do want to share with you the job sheet because it is important to know that these are available, and we highly encourage people to use job sheets because they will keep you from missing major information to the producers. It will focus you on plans and specs again because they're listed and spelled out. It will keep an O&M out in front of the producers so they understand what they need to be doing with it. And then, and I have to apologize, these pictures are not going to stay here because they're not quite good enough, but they were what we put in just to hold a place. So these pictures will get better. Some of you will have to notice that that's not a very functional, and it's a waterway. That's not the right picture. So I apologize for that, but we'll get that corrected. This again helps you, if you just fill this document out, you're going to get all of the plans and specs are listed right here. So we're asking for this information just to make sure that we've hit the plans and the specs. And this is something that will help the producer understand what they're seeding, when they're seeding it, and anything else that they need to know. Okay, so that is what a job sheet is. And I do want to visit the tech note, and we'll go to tech note 10, and that is designing, planning, and then managing and maintaining a vegetated filter strip. This picture is going to go too because it definitely isn't the right picture. So we've got a couple of edits yet to do here, but we're getting this pulled together. So we do need to use Russell 2 again because we have to be looking at that upland treatment to make sure that our contributing area has been addressed. And again, the biggest difference between new and old standard is in the past, we only looked at 300 feet up from surface water. Now we look at contributing area. And what that is anything that's going to flow across that filter strip needs to be addressed because it will put pressure on that filter strip. So we don't look at an artificial distance of 300. We are now looking at what is contributing. And in Russell 2, it's really pretty easy because you can do stretches. So you can see what is, what is that? Maybe you've got 18% on the top 100 feet, and maybe you've got 12% for the next 180 feet. You can do stretches to determine what's going to flow across that filter strip, and the TechNote will help you figure that all out. So I'm not going to spend a lot of time on any of this right now, but here's what they're trying to tell you is we want to protect the uplands, the entire upland length is going to deposit into the filter strip, and we want to make sure we're not going beyond what its capabilities are. So this will talk to you a lot about the Russell runs and which worksheet, what it's telling you, and where you get the information that you need. And then if you want to challenge yourself to calculate the ratio, and if you notice, that is not required in the plans and specs, but it is a good thing to do just to make sure that you haven't found a unique circumstance where it won't last the 10 years. But the formulas are all right there. And again, what the formulas are doing is they're looking at the filter strip as a percentage of the whole area that is flowing into that surface water. They're also looking at not only the percent of the whole, but they're looking at that what's being trapped above it, what's flowing into it, and then what is being trapped in the filter strip. And then they're looking at the length of time that it'll take for it to fill up. And it needs to calculate out to something over a 10-year. So I've done a lot of math, and everything that I'm running now with the 20 and 30 minimums are acceptable. But I tell you that only if we're not being fooled by what's happening in the uplands. I tell you that also it will work as long as we have a decent sediment trap in our filter strip. So if we've got those two things under control, the filter strip is a really excellent way to protect our surface waters. All right, so this is just the basic math. It's not as hard as it felt when we had a pretty complicated TechNote. It's here, it's straightforward, and I think you will have no problem figuring out how to run a few examples if you're not comfortable making sure those filter strips will last. I like the rest of this because it talks about some of the conditions where you need to really pay attention and make sure that you're addressing things. Conditions where filter widths have to be increased. Nutrient and pesticide applications are applied without incorporation. Also note that if you've got an over application of manure, a filter strip is not your ticket. You've got to keep that upland treated, and upland treatments with nutrient management is equally important to soil loss. So if we're dumping a lot of manure out there, a filter strip doesn't have a chance to offset that. So there's a lot of other things that go into the picture when defining whether this filter strip is going to be successful or not. Winter spreading, we need to be really careful for that spring melt. We need to really pay attention to all of the factors associated with good resource management and good planning criteria. When we talk about managing it, what do we need to inspect? And this is going to talk a little more detailed than what the practice standard says. And there's a little section here in making sure that you understand grazing and mechanical harvest and what you need to know there. And here again, for grazing, they want to make sure you've got a pretty hefty grass mix. Grass, obviously, is what we're after, not legumes. So there's going to be that caution here. Then prescribe grazing mitigation. So if you are grazing, what do you have to know? What do you need to be careful of? And then there's wildlife suggestions as well. So that is the tech note, and we have the job sheet, and we have the practice standard. So see what time it is. We've got plenty of time, so I'm going to spend just a few minutes giving you a once-over on upland treatments. And I do this not to insult anyone's intelligence, but I do this because I don't think we really focus on it as much as I would like us to. So I'm just going to make sure we spend enough time here that we don't miss some of the upland treatments. Why am I struggling here to get this? Basically, I just want to say this is just us assessing those uplands because I cannot say it enough. If you do not have T, this standard is not going to do us the good that we need it to. Of course, it's going to do something, but it's just not going to be meeting the practice standard. So what does T look like? Tolerable soil looks like you've got control over your sheet and rill. You do not have rill, or if you do, it's very insignificant. There is no ephemeral erosion, and again, ephemeral erosion is the stuff that you can farm across. And there are no active gullies that are not treated going into that buffering area. So that's what T should look like. Probably have a lot of other practices on those uplands. We may have cover crops, we may have upland buffers, we may have residues pretty decent, we have good distribution of residues. We have things in place that need to be there. We have grassed waterways that are treated and that are actually trapping sediment and doing a good job, so we don't have to worry about that concentrated flow that's not treated. We may have terraces, we may have buffers, we may have good practices on those uplands. We have troubles when we have other things that need hard practices, but we just need to pay attention to what's going on these sites. So stable outlets is a key part of whether we're doing an adequate job of filtering from uplands. We may need to have clean water diversions associated. We need to be looking at the slope and the hydrology risk. So we just have to have that big awareness of what's going on in that entire watershed when we're out there, or at least in that contributing watershed, I should say. So our widths have to be factored bigger than math. And what I'm saying there is the math formula is pretty minimal. It tells you what minimums are, but when you're out there and you're seeing obvious problems, you've got to get bigger than a minimum because it's not going to address it. So we talked about where buffers work, where they don't. If you've got a lot of manure flowing in, you've got something to deal with. And so here we just have a crossing, but basically we've got a stream corridor that's got some treatment on it. Here I've shown you a picture where you've got a grassed waterway, but this is one that was recently built, but what you're seeing here is that's not a stiff-stemmed grass, that's just laying down and letting the water flow. So we want to make sure that it can handle and trap the sediment to do a good job picking your seed mix as well. All right, so then we talked about the importance of making sure we're factoring in that manure management on the uplands is occurring. Soil health belongs in every practice standard. It's not a standalone. It's part of what we do. So I can't say enough that understanding infiltration and doing everything we can to make sure we have good infiltration on those uplands and that soil health is being addressed and is part of our planning process is going to take us a long way to making sure that our filter strips are functioning as well. So soil health needs to be part of every single practice standard, and that's me on my soapbox again. But I really truly believe that. So we're looking at those residue levels. We're looking at treatment next to the stream. We're just trying to make sure that we've got it all accounted for. And that is it. So I'm sorry if I went off on a little tangent here, but I cannot stress enough that if we do not treat our uplands, filter strips will not do what we need them to do. So that's enough out of me. That gives you about 15 minutes for questions.
Hi, Judy. There was one question about where someone can find the filter strip worksheet.
The job sheet? All right, I'm going to take you there because I want you all to know. So we're going to go on a journey to find it. So the first thing we need to do is get to Wisconsin's Field Office Tech Guide. Everything regarding practice standards is in section 4. Everybody does know that. The tech notes are located right here in this folder. We're trying to keep the tech notes with the practice standard, but on occasion it gets away from us. So the reason I'm telling you that folder exists is because that's where I found this tech note, and I did not find it in the 393 standard. That's a mistake on our behalf, so we will get that in there. But it's there, it's just in that folder. So let's go to the filter strip standard, and here you'll have the practice standard itself. The job sheet is right here, and then the statement of work is simply what are the deliverables if you're working with somebody that's helping you with the practice standard. This is just more or less another way of saying what are the plans and specs. So the job sheets are the sheets that I'm referring to that help you and tell you what is this practice standard all about, what's the O&M, and then most importantly, where do I document the plans and specs, and there it all is in the job sheet. Does that answer that one? And as you go down through practice standards, you will see most of them have job sheets for Wisconsin. We have been working very hard to build good job sheets to help you with planning and to really help get plans and specs captured so we don't accidentally leave a landowner without some piece of the knowledge to keep these things in good shape. Okay? Anything else?
If anyone has questions, you can unmute yourself or send in a chat. That's how we found out the other one about this filter strip worksheet. They sent in a chat. So please feel free to ask any questions you have of Judy.
Hi, I'm wondering what happens when these filter strips become saturated in about 10 years. Is there any management technique?
Yes, we need to reestablish them, and sometimes that requires dosing them, not usually in Wisconsin, but if they're completely sedimented in, we just start over. It means it's going to make it 10 years if all conditions are accounted for and all things are normal. And after big rain events, I've seen a lot of filter strips that failed right now because we get a massive sediment load from some horrible event that we did not anticipate. We're out there with the dozer and reestablishing, and that's just it. So good question.
Judy, there's one, is the calculator for getting the width in Russell 2?
Yeah. I'm sorry, what?
The question was, is the calculator for getting the width in Russell 2?
No, the Russell 2 is going to give you the factors to make sure that you're at tolerable soil loss and that it's going to meet that 10-year. So the formula is in the technical note, and it's going to ask you, what is Russell telling you? In other words, in that first stretch, what's your soil loss? In the next stretch, what's your soil loss? And then in your last stretch, what's your soil loss? And that's all part of that formula to know that it's going to meet that 10-year flow. Hopefully, is that capturing that question? Russell's not going to tell you your minimum width. It's going to tell you your soil losses, and then you need to go to the tech note to determine that it meets. And if you find one that doesn't meet, please immediately send it to me, because I'll be shocked and in awe that you found it, and then we'll figure out what's going on. Okay? So, and I think I have a message from someone else who wants to contribute something, and so this is the time to please do that. I'm not sure I'm smart enough to send you back a response, but you sent me something, and hopefully I just voiced that. So if somebody wants to go and take us somewhere and show us something, I am willing to share my screen.
Judy, there was a question that I received. Is there a maximum width for equip purposes?
For equip purposes, no, I'm not aware of any maximum width. CRP does have some maximum width. I would say that 120 is probably considered a maximum width in Wisconsin because that's the number we've been using all along. But if you have a landowner that wants to go further than that, or 150 perhaps, because they're concerned about something specific, we can certainly consider that. Be very careful with CRP and CREP because there are program-specific rules on that.
And regarding someone maybe want to share their screen, sometimes that's just it says, can you make me the presenter? Those we ignore. Those are just how people log in. So if that's what you're seeing, Judy.
Yeah, I did, and I
Okay,
don't know what to do.
right. No, learned that one once when I made somebody else a presenter. So that's not really a real.
Oh,
so
that might have horrified them.
But otherwise, any other questions out there? I did shoot out in the chat line to everyone a quick survey that I would like you to take. We're trying to evaluate all of our training statewide, and if you would take a few minutes just to go to that link and fill out that survey, that would help us in the future for when we plan different trainings.
And please feel free to be terribly honest. I can handle it.
Right, because we don't know who they come from. They're anonymous, so please feel free to share what your thoughts are. Jan Kutcher just asked if there's some tech notes locations.
Okay, yes, I'll go through that again because I don't want anyone to miss this, but it is everything is in the Field Office Tech Guide, Section 4. And again, the practice standards themselves are there. And I will tell you, let's go into, I'll just do an easy one, conservation cover. Let's just say you will see the seeding calculators there. Everything that you need should be right there. But here on the filter strip, I did catch that we need to get the tech note in there, but have no fear, it will be in there. But even if it is, just realize that it's another folder down below. All tech notes are right here. It's an agronomy tech note. So we have pest management tech note. We have residue management tech note. Or we have grasses. We've got warm and cool season grasses, and we've got a cover crop one, and we've got a companion drop document here is for the 393. This is the one you're looking for, which is 10. Okay, so that is readily available. Good questions. And I guess the thing I do want to make sure the whole state knows is that we're always open to input on practice standards. If there's something like, I hope you considered this and maybe we should consider that. We're always welcoming input. If you have questions on practice standards, we always welcome questions so that you fully understand what the thought processes were. Someone asked me the other day, do you just create these all by yourself? I absolutely do not create these by myself. Never would I do that. They start out on a national team, and the national standards come down. They're pretty well vested by a lot of people. They're posted for several months. A lot of players add in and adjust them. And then we take them here in Wisconsin, and then oftentimes they're put through a SOC process, and if it's just simple little updates, they're not put through the process. But I just wanted you to have that awareness.
Excuse me, Judy, there's another question. It says the planning criteria references a filter strip worksheet. Is this the tech note?
The filter strip worksheet. We should change the language because Wisconsin calls that a job sheet, and that's what we're talking about. The job sheet is the worksheet we use to capture everything that needs to be captured. So thank you for pointing that out. I might not have even noticed that. We probably should be calling them job sheets. That's what we call them.
Okay, we have another one. Could we piggyback land out of production easement cost sharing with filter strip cost sharing, or choose one or the other? Did you catch that?
Yes, I did.
Okay.
You got a question that is definitely too specific to be asking me, because depending on what the program is, it depends on the program rules. If it's, you got to be really, really careful because CRP has totally different rules than EQIP. CSP, different rules than EQIP. There are state programs, there are county programs, different rules. So you really do need to know which program and look at the rules associated with the program. If you're asking me specifically, can you enroll, maybe it's an existing CRP field and just leave the bottom edge as a filter strip, I think that one you need to send in because my estimation is you probably will not, I don't know, I'm not answering it, because you really got to pay attention to the programs, and I'm only talking technical at this point. From a technical standpoint, boy, anytime we can get sod anywhere, we all win. So, and I think we all know that. Okay, but it's a good question. I'm going to go back to that question as I read it, unless there's some other question. I just want to make sure everybody's clear on the CRP side. This one haunts us occasionally, where they're talking about the non-cost share portion. We have a situation in CRP where obviously you can only put CRP and CREP on cropland that has that crop history. But oftentimes it's almost always the case where you have some additional area between the surface water and the edge of that field. That has to go under contract because you can't let something bad happen in there. So it has to be under contract, but it can't be paid for. So that's an example where you really got to know your program and understand the program rules, because every program is so different than the other one. Okay? Hopefully that makes sense and I didn't confuse you further. All right. I really appreciate your time today, and especially giving up your lunch hour. That's really excellent. So thank you so much for joining me and letting me share with you what I know about the 393 filter strip standard.
And hopefully you join us again next week on Wednesday at noon. And Judy will be joining us again to talk about no-till and reduced till residue and tillage management.
Yes, I will. I'm sorry to say I do not have an agronomist yet, so I will be the person that will be chatting with you.